All right, greetings, you little apes, hoodlums. We are going to continue to press on through Unit 3. Today we'll focus in on topics 3.7 and 3.8 with an enduring understanding that human populations change in reaction to a variety of factors, including social and cultural factors. The reading, I do implore you to please read sections 8.1 and 8.2, pages 206 through 214 that accompanies this from the Miller textbook. So we're going to begin with some global population statistics, just some good to know, need to know numbers. So as of 2024, the estimated global population is 8.1 billion. We do say estimated because it's very difficult to count all those people, particularly in areas with not very good census data. But we're pretty confident it's in the ballpark of 8.1 billion people. And sometime in the next 25 to 26 years, we are expected to achieve a population of between 9.5 and 10 billion by 2050. And interestingly, we might start to see the population level off sometime after that, pretty within 10 to 25 years. Now, the current global population rate is 0.9%. Now, to put that in perspective, 0.9% doesn't seem like a lot, but 0.9% of 8.1 billion is small percentage of a really big number. So we still end up with a lot of people being added to the planet every year. So to kind of put that in perspective, 0.9% of 8.1 billion, adds about 73 million people, right, per year to the planet. And again, this is the net increase. This is counting the people that also die. This is the total additional people one year over the other. And so if we could think about it, the global population at this rate would grow by one whole United States population every 4.5 years. Okay, so just think about that. Every 4.5 to 5 years, another United States worth of people are added and living on the planet. And that's still quite a bit. Now, it is also worth pointing out that 0.9% is likely to decline. So we're not really going to add that many people as quickly, but it's still a lot of people. And so if we look at the chart over here on the right, projected population growth rate. So if we look at this line right here, we can see that that has declined, and we expect it to continue to decline well through the rest of the century. Okay. Now, any growth above zero is still growth, though. So even if it's a 0.3 or 0.2% global population growth rate, that's still going to add people to the population. Population will continue to grow, which is why this line over here continues to increase. And you'll see that it looks like around 2050, we're between 9 and 10 billion as expected. Okay. Now, this is expected to decline. And probably sometime during this century, we will see that reach zero or perhaps even go negative, as it has in other countries. Okay, looking globally, India is our largest country in the world now, just recently been surpassed China. India is growing at a 0.81% growth rate. China, which was for a long time our largest country, has entered a phase of negative growth rate. That means that in terms of people moving out of the country versus in number of births versus deaths, that number has become negative. China's population is expected to decrease. The U.S. has a population of about 345 million. We're growing at a 0.57% growth rate. Most of that, however, is immigration. We're just at or maybe even a little below replacement fertility. Indonesia is growing at 0.75% at a population of 283 million. And Pakistan is our fifth most populous country, growing at 1.9%, 96%, almost 2% growth rate. Now notice that is well over double the growth rate of the other four most populated countries. So Pakistan's population is skyrocketing, as is Nigeria, which is a close sixth place here. All right. Now, let's put this in perspective. Let's go back to this idea of ecological footprints. So we have 12.2 billion hectares of ecologically productive land. Now, that provides about 1.5 hectares per person. of productive land. So that means to live sustainably, we need to get ourselves down to 1.5 hectares per person. Okay. Now in 2050, if population continues to increase, that number will get down to trying to live off of 1.22 to 1.28 hectares per person. So the global average footprint is 2.7 hectares per person, which is way higher than what's actually available. And again, we are able to do that through the use of things like fossil fuels, non-renewable resources. So as it is right now, we need about 1.9 Earths to sustain our current population. And in 2050, we'll need about 2.2 Earths to sustain that population. Okay. Now we can superimpose that over the average U.S. citizen, which is about 8.6 hectares to support our lifestyle. That number has actually been down from about 9.5 just a few years ago. So the U.S. is beginning to do a better job of living more closely to within our means, although we're still way outside what's actually sustainable. And the global average per capita footprint is expected to grow because most of the population growth is expected to happen in the developing world. And in the developing world, they are expected to see a higher standard of living, which does bring their ecological footprint up. Okay, almost done with statistics. So going back to this idea, most of our population growth, 95% of it, in fact, is expected to happen in less developed countries. So you'll notice this yellow region down here. This is the population of the developed world. That population looks like it's about leveling off or has leveled off. Okay? Most of this growth in global population is expected to happen in less developed countries. That has all kinds of implications that we will get to later. All right. Now, we also want to think about where these people are living. So globally, we are rapidly urbanizing. So currently, about 55% of our population lives in what are called urban areas. Now, by 2050, that number is expected to be up close to 70% at 68%. Now, in 2005, when I was just a young teacher, that was just under 50% of the population lived in urban areas. And in 1960, when my parents were young, that was just under 35%. So that is quite a trend. So a mass movement of people to these urban areas. We have a whole lesson on urbanization happening later in the year, but that's an important statistic. So the urban population currently is greater than the whole 1960 global population by more than 1 billion. So if we're going to get our population living within its means, we better figure out how to make cities efficient. So just a little taste of what's to come. All right. Now, carrying capacity versus cultural carrying capacity. So we want to think about, so what can the Earth actually support? This number is debated and argued about wildly. So carrying capacity, if you guys remember, is the maximum sustainable population. It's usually used in the world of ecology and understanding populations that aren't human, because it's a very complex thing when we factor in humans. So when we're talking about carrying capacity for humans, are we just talking about how many people the Earth can support indefinitely to food, get us fed, and provide us with space and water and things like that? Or are we talking about the maximum number of people who can live in reasonable freedom and comfort? Or are we talking about the maximum number of people who can live in reasonable freedom and comfort while leaving space for other organisms we share the planet with? Now, assuming we need those organisms, we're probably aiming for that third bullet point. And what does that number look like? We can maybe chat about that in class a little bit. All right. So total fertility rates, you guys should have already done a quick reading, so I'm going to blaze through this really quick. But it's defined as the number of children born per female. So it's an average. So if you take the females in a country, for example, and you look at the average number of children they have over their lifetime, that is total fertility rate. So replacement level fertility, that just means if we want to maintain a population indefinitely, that would be 2.1 births per female on average. The 0.1 accounts for infant mortality, inability to reproduce in future generations, et cetera, et cetera. So just need an extra 0.1 to maintain that. So just think about it as 2 parents equals 2 children. Those 2 to 2, that maintains a population. We do want to know that number right there. Super important. Okay. The global fertility rate is 2.5, down from 5.0 in 1955. So that extra 0.4 per female is what's accounting for that about 0.9% global rate of increase. Now, if we look at it over different parts of the planet, Africa is by far the highest fertility rate on average. That continent has a fertility rate still above 4. And we can look at other parts of the world. So if we look at, so here, this black line up here is Africa. We can look at most of North America and Europe. Down here, we are below replacement level fertility, as are places like Japan, etc. But notice that regardless of where we are, that fertility rate has fallen in the last 50 years significantly. Africa is just, because of demographics, which we'll get to later, is just a little bit farther behind in terms of that decrease. So what affects fertility rates? Now, first of all, we want to remember this. The single biggest factor affecting fertility rates is the status of women in a society. In other words, do they have access to education? It is the number one indicator of fertility rates. So along with that, so do they have access to education and career pathways? Do they have reproductive choice? So do they have access, to contraception and birth control? Generally speaking, when they are more educated and seek careers, the age of that first child also comes later, which reduces fertility rates. Now, other important factors would be things like religion. Sometimes religion influences how many children we decide to have or how important having a lot of children is. And of course, infant mortality rates. As infant mortality rates go up, the total fertility rate tends to also go up to account for higher infant mortality rates. So here are some interesting data. Fertility rates in the U.S. So this is U.S. fertility rates. Early 2000s. Okay. And we can see that with higher education, the fertility rate decreases. We can also look at access to contraception. So if we have access to modern contraception, as the access increases, the total fertility rate decreases. And essentially, without access to contraception, fertility rates won't go down. More educated people don't stop doing the things that make babies. They just have more control generally over their access to contraception and more choice in when they start having children. All right. Now, closing in on the end, we can look at global versus local population. We don't have just fertility rates. So fertility rates are important. That is births and deaths. We have to also account for things like immigration and emigration. Some other important variables would be life expectancy. So the longer people are living, the slower the decline of a population will occur. How many years are between generations? Are we talking the average gap between parents and children is 20 years? Is it 18 years? Is it 30 years for the average age of the first child? Of course, infant mortality rates are going to be important. Famine, war, disease, immigration, and emigration. Of course, all these things are going to impact the growth rate of an area. Okay, that takes us to the end. So kind of in summary, fertility rates are the average number of children born per female. 2.1 births per female is what's considered replacement level fertility. Globally, fertility rates are declining. Most population growth is expected to happen in the less developed part of the world. And of course, factors that affect fertility rates are things like number one, the status of women in society, but also religious and cultural beliefs, etc.